When upgrading electrical service, it's important to correctly size breakers and panels according to the National Electrical Code, specifically concerning continuous loads. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. The National Electrical Code stipulates that the maximum continuous load on a circuit breaker should not exceed 80% of its rated capacity. This rule is designed to prevent overheating and potential failures of the breaker and connected equipment. For example, a 600 amp breaker should not be subjected to a continuous load exceeding 480 amps, which is 80% of 600 amps. If the load is 560 amps, and one considers using a 600 amp main breaker and panel, this would not meet the National Electrical Code requirements. The 560 amp load exceeds the 480 amp maximum continuous load allowed on a 600 amp breaker. Using a breaker loaded beyond its 80% continuous rating can lead to nuisance tripping, overheating, and potentially hazardous conditions. There are breakers designed to handle 100% of their rated capacity as a continuous load. These are known as 100% duty breakers. However, even with a 100% duty rated 600 amp breaker, the 560 amp load is too close to the breaker's capacity. It does not leave much margin for any additional loads or future expansion. It is also important to verify that all components in the system are rated for 100% duty, including the panel and conductors. For a 560 amp load, the recommended solution is to install an 800 amp system. This includes an 800 amp main breaker and an 800 amp electrical panel. An 800 amp system provides sufficient capacity to handle the 560 amp load while adhering to the National Electrical Code's 80% maximum continuous load requirement. Specifically, 80% of 800 amps is 640 amps, which comfortably exceeds the 560 amp load. Choosing an 800 amp system ensures safe and reliable operation with adequate headroom for future load growth. The steps to properly size a breaker and panel are: firstly, determine the total continuous load. Secondly, ensure that the breaker's rating is at least 125% of the continuous load, or conversely, the continuous load does not exceed 80% of the breaker's rating. Thirdly, select a panel with a capacity equal to or greater than the breaker's rating. Fourthly, verify that all components, including conductors, are appropriately sized for the calculated load and breaker rating. To elaborate on conductor sizing, conductors must be sized to handle the load they will carry. The National Electrical Code provides tables such as Table 310.16 in the 2008 National Electrical Code, which specifies the ampacity of conductors based on their size, insulation type, and installation conditions. For example, if using copper conductors with THHN insulation in a conduit, one needs to consult Table 310.16 to determine the appropriate conductor size for the expected current. Conductors must be protected against overcurrent using appropriately sized circuit breakers or fuses. The overcurrent protection device should be sized to protect the conductor's ampacity, as specified in the National Electrical Code. Conductors should be derated for ambient temperature and the number of conductors in a raceway, as outlined in the National Electrical Code Article 310. These derating factors reduce the allowable ampacity of the conductors, and it is important to account for them to ensure that the conductors are not overloaded. The electrical panel must be sized to accommodate all the breakers needed for the various circuits in the electrical system. The panel's ampacity rating should be equal to or greater than the main breaker's rating. The panel should have sufficient physical space and available slots for all the required breakers, including spare breakers for future expansion. Verify that the panel is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, to ensure that it meets safety standards. Grounding and bonding are critical aspects of electrical safety. The grounding system provides a low impedance path for fault current to return to the source, which helps to quickly trip the overcurrent protection device and minimize the risk of electric shock. The bonding system connects all non-current carrying metal parts of the electrical system together to create an equipotential plane, which further reduces the risk of electric shock. The National Electrical Code Article 250 provides detailed requirements for grounding and bonding. Grounding electrodes, such as ground rods or metal water pipes, should be installed to provide a connection to the earth. The size of the grounding electrode conductor should be based on the size of the service entrance conductors, as specified in the National Electrical Code Table 250.66. Bonding jumpers should be used to bond together all metal enclosures, raceways, and equipment in the electrical system. Surge protection devices are designed to protect electrical equipment from voltage surges caused by lightning strikes or other transient events. Surge protection devices should be installed at the service entrance and at downstream panels to provide comprehensive surge protection. The surge protection devices should have a voltage protection rating that is suitable for the electrical system voltage. The National Electrical Code Article 280 provides requirements for surge protection devices. Before beginning any electrical work, it is important to energize the circuit or equipment being worked on. This can be done by turning off the circuit breaker or disconnecting the power supply. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Lockout-tagout procedures should be followed to prevent accidental re-energization of the circuit. Wear appropriate personal protective equipment, such as safety glasses and rubber gloves, to protect against electrical shock and other hazards. All electrical work should be performed in accordance with the National Electrical Code and other applicable codes and standards. If you are not qualified to perform electrical work, hire a licensed electrician. They have the knowledge, skills, and experience to safely and properly install and maintain electrical systems. When selecting an 800 amp system, it is important to consider the available space for the electrical panel and the ease of installation. The 800 amp panel will be larger and heavier than a 600 amp panel. Ensure that there is sufficient clearance around the panel for access and ventilation. The installation should be performed by a qualified electrician in accordance with all applicable codes and standards. Regular maintenance of the electrical system is essential to ensure its continued safe and reliable operation. This includes periodic inspection of the breakers, panels, and wiring. Breakers should be tested to verify that they are tripping properly. Wiring connections should be checked to ensure that they are tight and free of corrosion. Any damaged or worn component should be replaced promptly. If you notice any signs of electrical problems, such as flickering lights, burning smells, or sparking outlets, contact a qualified electrician immediately. Attempting to repair electrical problems yourself can be dangerous. When choosing between a 600 amp system with a 100% duty breaker and an 800 amp system, the 800 amp system is generally the better option. While a 100% duty breaker may be suitable for a continuous load equal to its rated capacity, it does not provide much margin for future load growth. An 800 amp system provides more headroom and flexibility. It also ensures that the system operates well within its rated capacity, which can extend the lifespan of the equipment and reduce the risk of failures. In addition, an 800 amp system may be required by local codes or regulations, depending on the specific application and load requirements. The National Electrical Code is a comprehensive set of standards that governs the safe installation and maintenance of electrical systems. It is important to be familiar with the National Electrical Code requirements for breaker and panel sizing, conductor ampacity, grounding and bonding, and other aspects of electrical safety. The National Electrical Code is updated every 3 years, so it is important to use the latest edition. Local codes and regulations may also impose additional requirements. Consult with a qualified electrician or electrical inspector to ensure that your electrical system complies with all applicable codes and standards. In summary, when upgrading electrical service for a 560 amp load, an 800 amp system is the recommended solution. This provides sufficient capacity while adhering to the National Electrical Code's 80% maximum continuous load requirement, ensuring safe and reliable operation. In addition, the 800 amp system is the best option to install and maintain in the long run. Remember to always consult with a licensed electrician to ensure compliance with the National Electric Code as well as any additional state and local regulations. Also, ensure that the licensed electrician acquire all necessary permits before beginning the installation. After installation, call for an inspection by your local municipality to sign off on the work. Make sure to keep a copy of the permits and inspection sign-off with your important documents. Keep in mind to stay safe and to not conduct any electrical work yourself. Without the proper training, knowledge and equipment to do so, you risk hurting yourself or others. If you have questions, please reach out to a licensed electrician. A licensed electrician is a trained professional that is up to date with all the codes and standards that are applicable in your area. Remember that the National Electric Code can be updated as frequent as every 3 years. Changes to the National Electric Code occur frequently to ensure a safer work environment as well as to keep up with the new advances in technology. The National Electric Code is a set of rules that, when followed, ensures a safer work environment and reduces the risk of injury. It is important to stay current with all of the updates that are released as well as your local area laws. All municipalities adopt the National Electric Code but will also provide supplements that are specific to your area. Some municipalities may require more stringent rules than the National Electric Code itself, and it is important to follow those. It is also important to know that the latest edition of the National Electric Code isn't always adopted by every municipality. Some local areas are still working from previous versions of the National Electric Code. For example, the 2023 version of the National Electric Code is the most recent version at the time of this recording, but some areas may still be working from the 2020 version of the National Electric Code. However, that doesn't mean that the previous versions are obsolete. Any electrical installation that was previously installed according to a version of the National Electric Code is still in compliance. The important aspect is that when it was installed, it was up to code at the time of installation. However, it is also important to consider when doing an upgrade or alteration to an existing electrical system that the portions that you are upgrading should be upgraded to the latest code for the municipality. This is to ensure a safe work environment for everyone. There are also federal and state laws to consider. State and federal laws supersede the National Electric Code in most situations. Most of the time, state and federal laws focus on licensing requirements and may also require certain installation methods. These installation methods become law and therefore must be followed. Usually, when something becomes law, that means the penalty for not following that law is stricter. This could lead to heavy fines or imprisonment depending on the specific situation. Therefore, you should always contact a licensed electrician to do the electrical work for you. A licensed electrician will be aware of all federal, state, and local laws and codes and can ensure a safe and professional installation. The steps to properly size a breaker and panel are: firstly, determine the total continuous load and determine the total non-continuous load. Secondly, multiply the continuous load by 1.25 to get 125%. This value should be less than the value of the circuit breaker that will protect the load. Thirdly, add the non-continuous load to the continuous load to arrive at the minimum size breaker. Fourthly, determine the wire size to be used to feed the load. Note that the wire should be rated for at least the value of the circuit breaker. Fifthly, determine the ambient temperature and the number of current carrying conductors in the conduit. This may require you to direct the wire to a lower ampacity. It is important that after directing, that the wire can still handle the load and is rated for at least the breaker value. If not, you need to increase the size of the wire to accommodate the load. Sixthly, ensure that the panel has the capacity to hold the size breaker that is required and ensure that the busbar is appropriately sized. The busbar is the metal bar inside the electrical panel that feeds the circuit breakers. The busbar needs to be able to carry the full load of all the circuit breakers in the panel.